Hello student, in previous class I have discussed about block diagram and the need for block diagram reduction technique. So in this class I will discuss the block diagram reduction technique. So when we want to reduce the block diagram, then we must follow these rules. So let's start our discussion. So first rule is if blocks are connected in series. Okay. So see the diagram. So when you saw two blocks in block diagram are connected in series, then no need to consider the two blocks as individual blocks. So you can combine these two blocks by a single block like this. You can multiply the gain of each block and you can make that as a single block. So as we are having X is the input signal here, so that is multiply with the gain of the block, and the output is here, the output is X into G1 into G2. Okay, now come to this structure. Here the input signal is X and that is tending to block having a gain G1, and so after that passing through the first block, so the value from the output of this first block is equivalent to Xg1. Now this Xg1 is passed through next block and multiply with this block gain G2. So totally this block output is equivalent to Xg1 G2. Okay, so the output of this is also Xg1 G2. So if you consider block like this, also you are getting the same output. Okay, here we also getting same output and here we also getting same output. So our intention is get the same output by taking individual blocks or combined block. You need to get the same output. So if you are getting the same output by taking this simple block, then why to need to take two blocks? So that's why we can reduce these two individual blocks by combining the two blocks with multiplication of gain. So if you observing the block in series, then you can combine by using multiplication. You can make them as a single block by using multiplication of gain. Now come to the next rule. Next is parallel connection. Here, when we are combining parallel blocks, you need to observe at summing point. When we can say the blocks are in parallel, when blocks are like this, okay, and with a summing point. When blocks are like this with this summing point, and these two blocks are said to be in parallel. So how we can combine these two blocks? So here I can combine these two blocks by using addition. Whatever the parallel blocks are there, that parallel blocks we can combine by using only addition. So addition means, what is the addition? Addition means just by adding the gain. Gain means G1 or G2, means G1 plus G2. We are going to get the same output by adding the gain. Okay. So here you can see here you can given with x, you can given with x, means this x signal is going to this block and this same signal is going to this block. Okay, so this block output is xg2 and this block output is xg1. Okay, and the total output and the final output after summing point is xg1 plus xg2 are combined by this summing point, and this form is x into g1 plus g2. So for example, same input signal x is giving here, see this case where we replace these two blocks by a single block. Here the input is same x. Okay, x is giving here, and the output is also x into g1 plus g2. That is equivalent to this previous output. Okay, so you are getting the same output. If you are getting the same output with this single block, no need to take these two blocks in parallel with branching point or summing point. So this is the reason why we require combining of blocks with a single block we can do here. Thank you, student.